right, let's try this one out. Part B, integral of 4x squared plus 2x minus 6 all over x to the third plus x squared. Let me try and get my camera a little bit lower so it's not so small on the screen. Okay, I think that's a bit better. What are we going to do here? Well, we notice that our denominator, we'll use partial fraction decomposition to begin, of course. And we'll notice that our denominator is not factored. So typically, they're not going to give you factored denominators. Sometimes you'll see that, and that's nice, but usually you'll have to do that on your own. So let's take a look. And here I actually just set up the whole thing, but we'll kind of talk through this. Okay, so there's the original expression. When we factor that denominator, we'll just factor out an x squared, leaving x squared times x plus 1. And we'll say, oh, okay, so we've got a squared factor. Think of the factor as x, but then it's being squared. So we need a over x plus b over x squared plus c over the x plus 1. Now you may be wondering, hey, in a case like x squared, could we think of that as an irreducible quadratic? And actually, yes. Instead of these first two here, you could do ax plus b over x squared. And that would be perfectly fine, and that would replace both of those. You kind of look at that for a moment. Wait, these are equal. A over x plus b over x squared is the same as ax plus b over x squared. Those are the same thing. So obviously you can go with either one. I prefer this style compared to the ax plus b style here. Just a personal preference. Of course, you're going to get all the same values, but I find this, there's a little bit less work involved, a tiny little bit. Okay, so what do we do from here? So we're going to think of this part and this part as two sides of an equation. So I'm going to multiply x squared times x plus 1 over to this side, so it's going to cancel here. Oh, looks like I continue that on the next page. All right, here it is. So here it's going to cancel out, and we'll get the 4x squared plus 2x minus 6. And when it multiplies over here, okay, so a over x times x squared times x plus 1, well, one of the x's will cancel, and we'll get ax times x plus 1. When we multiply that whole thing to the b over x squared, the x squared cancels. We get b times x plus 1. And when we multiply it by c over x plus 1, the x plus 1 cancels, leaving us with c squared. But now we're going to continue in the same way we did that first example toward the beginning. I'm just going to go ahead and multiply everything out and then rearrange the terms. And I just went ahead and did both those things together. So let's see where this line comes from. Let's think about the x squared terms. Well, I have ax times x, so I'll have an a here. And I have the cx squared. Those are the two x squared terms. So let's just go ahead and put those together and factor out the x squared. What will be the x terms? Well, I'll have ax times 1 and b times x, so a plus b times x. And are there any constant terms? Yep, b times 1. There's my b term. So everything's been accounted for. Let's check. So I had ax squared, ax, bx, b, and cx squared. Yep, everything's there. And of course, it's still equal to 4x squared plus 2x minus 6. And then the critical step in the logic, okay, we're going to compare coefficients on the left and the right. So I've got my x squared term, my x squared term, my x term, my x term, my constant, my constant. So I know that a plus c is going to be equal to 4, a plus b equals 2, and oh, this is nice, b simply equals negative 6. So I've written all that here, boom, boom, boom. And because we know b equals negative 6, we can just get our answer really quick. So putting that negative 6 there, well, that means a equals 8. And if a equals 8, then c equals -4. Sometimes it takes a little bit more work, especially when you have a system of 3 variables, 3 equations, 3 unknowns. But, whatever you need to do, sometimes these are straightforward. Sometimes they take a little bit more work. Whatever you need to do to solve that system for A, B, and C doesn't matter to me. All right. Well, now we have our partial fraction decomposition. So we can think of our integral now as we had a over x plus b over x squared plus c over x plus 1. So here we go. 8 over x minus 6 over x squared minus 4 over x plus 1 when we plug those in. And now we can do each of these separately. And we got our final answer right there. We've got 8 natural log absolute value of x. Be careful, this next one is not a natural log, right? With x squared, maybe think of that as x to the -2. Do your antiderivative. You'll find yourself with plus 6 over x when you do that one. Minus 4, and now the natural log is back. Natural log absolute value x plus 1 plus c. There it is. Now that's pretty cool. If you really wanted to, you could combine your natural logs. You'd have to move your coefficients up. I find most people, though, just prefer it like that. And I'm not arguing. Okay. So I've got one more for us. This is a pretty cool one. Definitely need to highlight one of these. Part C, integral 1 over 2 times the square root of x plus 3 plus x dx. Okay, what are we going to do with that? Because we look at it, and I got to tell you, just at a glance, that does not scream partial fraction decomposition by any means. It's one thing if the denominator is not factored, but you can see the factoring, and it's a whole other thing if we get this sort of denominator. Okay, this one's tricky. It is going to be a partial fraction decomposition, but there's some work to do at the beginning. Turns out we need a u substitution. So what's a u substitution going to do for us, and what's that even going to look like? We're going to take u to equal that square root. Okay, so this isn't obvious. Who would think to do this? I totally get it. But that's why you're seeing it now, and that's why we're talking about it. So let's take u to equal square root x plus 3. Now, this is not going to be even a typical u substitution. This is kind of a sneaky u substitution. Because you think to yourself, okay, well, taking u equal square root x plus 3, what good is that even? All right, so this becomes a u, but there's still this other x. And when you take a derivative here for your du, we're like, I mean, how's this going to work at all? And you're absolutely right. Here's what we're going to do instead. Let's isolate the x. Okay, so we know this part can be replaced with u. What could the x be replaced with? Let's solve for x here. So we're going to square both sides and subtract the 3. Hey, wouldn't x equal u squared minus 3? Well, yeah. And then from there, let's go ahead and get dx. So this has like that dual purpose, right? So we're going to replace this x with u squared minus 3, but then we can also immediately get the dx to be 2u du. So we know how to replace the dx as well. Okay, this is great. Apologize for the large gap here in my notes. It's a bit weird, but okay. I think you can follow me here. All right, so what do we got? We got 1 over 2u plus u squared minus 3 times 2u du when we do this substitution. Now let's clean that up a little bit. And I will scroll down here. Ignore what's on this side of the page, please. Gonna hide that. All right, so the 2 here I'm just bringing all the way out in front. And then the u's on top, and if I rearrange, u squared plus 2u minus 3. Now it's starting to look more like a partial fraction situation. So we're going to factor the denominator. Turns out it factors very nicely. U plus 3 times u minus 1. Okay. And then we'll go ahead and set up our partial fractions. Now this is one of the simpler variety, which is nice. They're both just factors to the first power. So we'll say a over u plus 3 plus b over u minus 1. Okay. And then we'll just go through our steps. So let's multiply this denominator over to the right side, leaving us with u over here equals a times u minus 1 plus b times u plus 3. And then we'll distribute our a and our b and kind of regroup them. So a times u, b times u, I'd have a plus b, u, and negative a plus 3b. All right, negative a plus 3b is kind of added onto the end there. That's our constant. And then we compare the two sides. So I see, okay, here's my u term, and here's my u term. So a plus b must equal this coefficient here, which is 1. And what do we do about the constant? Okay, well, you can think of the constant on the left side as 0. So negative a plus 3b is going to have to equal. Sorry, everything's kind of small and unclear at this moment, but okay. A plus b equals 1. Negative a plus 3b equals 0. What are we going to do with that? You can solve these however you like. Solve these however you like. I decided to go with substitution here. I think it would work great to use elimination since the a's would immediately cancel. Well, let's go with a different style, substitution. Maybe you prefer that. So I'm going to subtract the b, and then I'll plug this in right here. And I'll just show you the rest of my work. Okay, so negative 1 minus b plus 3b equals 0. So that's going to be negative 1, so let's put that on this side. And then positive b plus 3b. I'd end up with 4b equals 1, so b equals 1/4. And if b equals 1/4, well, maybe I put that in right here. 1 minus 1/4 gives me a equals 3/4. Sometimes you might get fractions for a and b. Pretty common, actually. All right, now I'll show you what's going on back on. This is not, probably a calculator is not the best thing. Let me grab another piece of paper. Do it this way. All right, that's better. All right. So from this line, a was 3/4, b was 1/4, so we'll put those in. And remember, there was a 2 in front of the whole thing, so we got 2 integral 3/4 over u plus 3 plus 1/4 over u minus 1. Natural logs are going to save the day again. The 3/4, right? I mean, that's just a constant. So we got 2 times this whole thing, 3/4 natural log absolute value u plus 3 plus 1/4 natural log absolute value u minus 1. Big parentheses around all that, plus c. And of course, we had a u sub at the beginning, so we got to put our u's back into our final answer. And there it is. It just barely fits here on the screen, but those u's became square root x plus 3 in both cases. And I went ahead and multiplied out that 2. So we got 3 over 2 natural log absolute value square root x plus 3 plus 1 half natural log absolute value square root x plus 3 minus 1 plus c. And that's it. So you'll see a couple of problems in this style where you need some kind of a substitution to get started. So if you see something really strange, okay, no, somehow a u sub is involved. And that's all for this section. Good luck to you guys. Hope to see some of you in the live office hours.